super exciting. So these were our non-permissible values in grade 12 and grade 11. So now, if you do a direct substitution and numerator and denominator in the expression that are both 0, it's indeterminate form. So both numerator and denominator are 0. We've got to do some algebraic manipulation, which I'm sure you're excited about, to make sure we figure out what the limit is. Easy peasy. Well, the first one's really easy peasy. So example 1, if I have this and x is approaching 3, if I substitute 3 in here, I get 0 over 0. So this is an indeterminate form. The IF stands for indeterminate form. Okay? So we got to do some math in order to make it work. So this is where your grade, actually I think it's grade 11 skills come into play. We're going to simplify this. So we would take limit as x approaches 3. And then with this bracket, we're going to do some factoring. So this would be x plus 3, x minus, not 9. So now the technology is working, it's not my brain. All over x minus 3. See something we can do here? Cancel. So you had one of these questions on an assignment, right? It said simplify it to make an equivalent expression. So once you get into that equivalent expression, now we can do direct substitution. If we do direct substitution in this, all we're doing is dropping the limit, putting the 3 in for x. So we have 3 plus 3. So what's the limit of this one? 3 plus 3. Easy, the answer. So this limit, if we graph this, this would be approaching 6. So those ones aren't hard. That's grade 11 work, grade 12 work. That's going to go by really, really quickly. You guys are going to be brilliant at that, and it's going to get a little bit more complicated. What fun would it be if you didn't learn? Is everybody good with it? You got all the notes covered down? Wasn't really a lot of hard math. Okay, so for example 2, we've got a radical in there. And again, I did the direct substitution for you, 0 over 0, and we're in indeterminate form. So remember not to numerator and denominator. So we're going to need to get rid of that radical. Anytime you see the radical, we're going to try to get rid of it. Usually it's on the denominator when we actually rationalize the denominator. And when we actually do that in grade 10 or grade 11, and then we never have to do it ever again. I'm asking you to do it here, but now I don't care about the denominator. I need to get rid of that radical. I need to change something so I'm not 0 over 0. So I'm going to multiply by the conjugate. And we remember the conjugate being same terms. We just change the sign. The different square partner, maybe. Okay. So again, we always have to put in the limit as x approaches 4. And we're going to take root x minus 2 over x minus 4. And we're going to multiply it by the conjugate. So I only care about the radical. The only time we ever multiply by the conjugate is when we're getting rid of the radical. So normally we multiply the denominator. Now we're looking at wherever the radical is. It could be numerator or denominator. So what's the conjugate to root x minus 2? Root x plus 2. So that has to be both top and bottom, because that expression here has a value of 1. Okay, and you count by 1 is itself. Look at me, misuse of brackets. Well, my technology is working better today, so I'm less likely to cry. Okay, so here we go. Multiplying. root x gives me x. Root x times by a positive 2 gives me plus 2 root x. Negative 2 times by root x gives me minus 2 root x. And then negative 2 times by positive 2 is going to give me a negative 4. That's exciting. Now I have to work on the denominator. I'm actually not going to multiply the denominator in. I'm going to leave it as factors. And you'll want to do that. In the next step, you'll see why that's important. All right, so when we combine my terms, I'm going to have x minus 4. Oh my goodness, do you see something? You excited? No, nobody's really excited. It's Friday. Come on, we've learned some calculus. You're smarter people than you were on Monday. We're going to cancel it. The x minus 4. Thank you. I'm just trying to get you excited. We're a little class, and now we have to be more vocal. Okay? Now I can't blame it on the technology. It's just my forward writing. So the whole goal when you get into indeterminate form is to do something mathematical that changes the way it looks, but doesn't change the value. And then you wait, the variable wait. All right, so now we can do direct substitution. So if we do direct substitution, I'll have 1 over root 4 plus 2, so this would be 1/4. So the limit of this function, if I go way back up here, is 1/4. Do you guys think you can do that on your own? Easy peasy, right? All this is math that you've done plenty of times. I was thinking we could do 2 lessons today, but I think you're going to hate me after the final example, so we can assess how you're doing it happen. All right, you may hate me after this example as well. So this is all the things you train for in grade 11 and grade 12 is actually coming into how you calculus. So if you're wondering why we did all that crazy stuff, this is why. All right, so this one looks a little bit different. Again, with direct substitution, 0 over 0, indeterminate form. Okay. Common denominator is going to help you with this one. So, question of the hour. Remember, this is over one. What are the common denominators for this? For this expression. I'm doing so well. That's supposed to be a C. Common denominator. Right? Common denominator. If I look at here, what's the common denominator of the numerator? 2x. And the denominator of this one is 1. So 1 times 2x is just 2x. You're going to treat them as different. Sorry, Kevin. You were kind of on the right track. Is he messing with you? He needs you to wrong answer on purpose. Okay. So the easiest way to do this is you're going to multiply the numerator, the top and bottom, numerator, denominator, by the common denominator. So that's x, which is 2. So let's look at this. We'll make this nice and big. So 1 over x minus 1/2. So I'm going to take this whole thing and I'm going to multiply it by 2x over 1. And the reason why I'm going to write it that way is because on this denominator, it's also going to be multiplied by 2x over 1. This was just x. So really, you're multiplying the top and the bottom by 2x. Because you know 2x divided by 2x gives me a value of 1. Okay? I'm just showing it to you as fractions to help you with your multiplication. Are you okay? So top and bottom by 2x, easy peasy. So if I multiply 2x by this, what do I get? First term on the numerator. I'm left with just 2, right? And that's going to be subtracted. I multiply 1/2 by 2x. What am I left with? Just an x. And then on the bottom, I'm going to leave them again in factored form. Because I would multiply the 2x into both terms, but you're going to see that something magical is going to happen. Anything jump out off the page to you? Not yet. Yeah, the trick. If I need a positive x and if I need, sorry, a negative x and a positive 2, if I factor in -1 of this, it will change the signs of both of them. So you guys got to be able to see that. You got to be able to see it pop off the page. So if I take a -1 out, that's going to leave me with a -2 plus x. I'm just doing all the steps for you, so feel free to, if you see it and it jumps off the page at you right away, then feel free to skip as many steps as you need to. I just want to make sure we got them all down. So now it should jump off the page, but we're going to cancel each other out. And so I'm going to have the limit as x approaches 2 of -1 over 2x. I'm going to do some direct substitution, and I'm going to have -1/4 for the direct substitution. So this magic expression is approaching -1/4. Pretty easy when you get down to the math. Nothing you guys haven't seen before. This one will be a little bit different, and it will make a little bit more sense when we start crafting in the derivatives. That's what I'm trying to say. So the differentials, but we're not doing that. Okay. You can use function notation in solving limits. It'll be useful when we do rate of change in questions later on. So I remember this one to vote. They'll correct me for you. I'm going to ask you to trust me. So here's the thing. Okay, so all you're saying is that I can move some distance away from the function, and if I subtract the original function from it, it's going to get smaller and smaller. You can actually grab it. Okay, so now we've introduced a new variable. There's no x's in here. There's no x's because we're in function notation. So h is approaching 0. So that gap is getting smaller and smaller and smaller, but we're adding to the function. So the function evaluated at 1, you can put that in there. If you evaluated the function at 1, it is, like doing table values actually. It's going to be 2 minus 5, which is -3 plus 1, is going to be -2. So if I started adding a little bit onto 1, right, 0.5, 0.1, 0.01, like as those, when I'm adding onto 1 as it gets closer to 0, that's, you're going to start doing slope straight lines of the curve, and that's what this represents. I don't know if that makes any sense to you. It makes sense to me because I can see it in my head, but I'm probably just calling me a great read right now. Okay, so if I were to do this, if I were to say h is 0 and got into indeterminate form. So now we're going to do this. Mathematically speaking. Okay, so here's the deal. What usually goes here? X, right? Usually that's our x value. So what we're going to do in function notation form is we are going to use the equation So we're going to say the limit as h approaches 0, so this is going to get big. It's the only one on the page, so it's going to get big. So we're going to say, instead of x, we're going to say 1 plus h in your formula. So it's going to be 2 times 1 plus h squared minus 5 times 1 plus h plus 1. Okay, that's that part. Now, this used to be an x, so what are we going to replace it with? What's in here? It's a 1. So we're going to replace all the x's with 1. So this one's going to be 2 times 1 squared minus 5 times 1 plus 1. I'm going to put these in brackets because the negative has to be distributed through the whole thing. Okay, you ready? So all we've done is replace function notation with 1 plus h and 1. That's all we've done. Oh, and then it's over. What's it all over? H. Woo. That's a big one. All right. So the limit as h approaches 0. And so we're going to do all the steps because that's super fun. So we're going to have 2 times, and I'm going to do some math in my head, guys. I'm going to do some math in my head. Are you going to be okay, Kevin? If I expand this, and what I mean by expand is we're going to go 1 plus h times 1 plus h. And I bet you can all do it in your head. Because you're that good now. Minus 5 minus h. Nope. Obviously, I'm not that good. Minus 5h plus 1. Subtract, and what did I say this was? A negative 2. All over h. Holy, so much math. So 2 plus 4h plus 2h squared minus 5 minus 5h plus 1 plus 2 all over h. Too many plus lines there. Right. Never mind, I didn't write the 1. That's what I was. All right, so we're going to combine like terms. I don't have any other h squared, so I know I'm good with that. So what we're doing is, basic algebra. So I'm going to have 2h squared. That's gone. I got a positive 4h and a negative 5h, so minus h. And then I have 2 plus 2 plus 1 is 5 minus 5 is a big fat nothing. All over h. Anybody see what we can do to get rid of that denominator? Got rid of h. And so as h approaches 0, now my equivalent expression is 2h minus 1. Do some direct substitution, and what am I approaching? Negative 1. That's easy, right? How many times are we going to do that lesson? No? That was a big one.